To study the program based on array of structures, prerequisite 3. Let me derive the code for bubble sort. An example taken. You consider a floating point array with 4 elements 9, 8, 7 and 6. So here number of elements taken 4. The array is already in descending order. Using bubble sort, I am going to sort the array in ascending order. So using this example, I am going to derive the code for bubble sort. So inside the array, the various elements are like this. So A of 0 will contain the first element 9, A of 1 will contain the second element 8 and so on. Now to derive the code for bubble sort, we need two variables P that stores or saves the pass number. The word pass means a group of steps or a collection of steps, and variable L contains the index of the left element. What is left element? It will be explained in this video. So in order to derive the code for bubble sort, we need two variables, one P that contains pass number, and the word pass means group of steps. Variable L contains the index of the left element. Initially, we start with pass number 1 because step number always starts with 1. Now, in the case of bubble sort, always consecutive elements are taken and they are compared. So let me take the first consecutive elements. Let me compare the first consecutive elements. Now, when I take the first consecutive elements, you can see this is the left element, this is the right element, and variable L contains the index of the left element. So, for this left element, the index is 0. So, that 0 comes in variable L. Now, if you want to sort the data in ascending order, the question to be asked is, if the left element greater than the right element, you swap these two elements. And here in this example, 9 is greater than 8. So you need to swap these two elements. Yes, the elements are swapped. And the remaining elements, for the time being, there is no change as it is. So here 7 comes and here 6 comes. Now, the same pass, because pass means it is a group of steps, it's a collection of steps, so pass number does not change. Now let me take the next consecutive elements. So these two consecutive elements are taken. Now this is my left element, so index of the left element becomes 1. So now your L becomes 1 because L contains the index of the left element. Now, if you want to sort the data in ascending order, the question to be asked is, if the left element greater than the right element, swap. Here it is greater, so I need to swap these two elements. Yes, the elements are swapped because 7 came here and 9 came here. And the remaining elements, for the time being, no change. Here 8 itself and here 6 itself. Now same pass, because pass means it's a collection of steps. Let me take the next consecutive elements. So this is my left element. The index of the left element is 2. Let me note down the index of the left element here. Yes, the index of the left element is 2. Now ascending order, the question to be asked is, if the left element greater than the right element, swap. Yes, it is greater, so you have to swap. The elements are swapped. You can see 6 came here and 9 came here. And for the time being, remaining elements no change. So 8 and 7 in the respective positions. Now you can see the largest element came in the last column. So which means in the remaining passes, you don't have to consider the last column because the largest element, example 9, came there, or this column is fixed. So in the remaining passes, we won't consider this column because largest element came there. So one pass is over, one group of steps is over. Let me go to the next pass, pass number 2. Again, consecutive elements are taken. So let me begin with these two consecutive elements. Now this is my left element. So index of the left element is 0. Let me write the index of the left element here. Ascending order, the question to be asked is if the left element greater than the right element, swap. Yes, it is greater, so I need to swap these two elements. And for the time being, remaining elements, no change. Now, same pass, the next two consecutive elements are taken. Now this becomes my left element. So index of the left element is 1. So let me note down the index of the left element here. Now ascending order, the question to be asked is if the left element greater than the right element, swap. So here it is greater, so I need to swap these two elements. And remaining elements as it is, no change. So you can see the second largest element came in the second column, so that in the remaining passes I don't need to consider this element or this element is fixed. So one more pass is over, one more group of steps over. Let me go to the next pass, pass number 3. Again consecutive elements are taken, so I need to take these two consecutive elements. Now this is my left element. So index of the left element is 0. Let me write the index of the left element here. So variable L contains the index of the left element. I want to sort the data in ascending order. So question to be asked, if the left element greater than the right element, swap. Yes, it is greater, so I need to swap. And remaining elements, no change. Now you can see the third largest element of the array came here, which means in the remaining passes, I don't need to consider the third column or this element is fixed. Now this element cannot be compared with any more elements, and you don't have to compare because the array is sorted in ascending order. So this is the technique used in bubble sort. Always consecutive elements are taken and they are compared. Now based on this example, how do you derive the code for bubble sort? You can see pass number varies from 1 to 3. Now 1 we can generalize because pass number always starts with 1 or step number starts with 1. We never say step 0 or step -1. So this we can generalize. Now how can we generalize 3? When the array contains 4 elements, it is 4 minus 1. So in general, if n elements are there in the array, this will be n minus 1. So 3 we can generalize it as n minus 1. So your pass number P varies from 1 to n minus 1. Let me write the code for that. We know that I varies from 1 to 3. The equivalent C++ code is this. So if I say P varies from 1 to n minus 1, the equivalent code will be for int P is equal to 1, P less than or equal to n minus 1, P plus plus, because you can see here no change, and this 3 became n minus 1. Okay, so here 1 and this 3 became n minus 1. So this will become for int P is equal to 1, P less than or equal to 3 became n minus 1 and P plus plus. So P varies from 1 to n minus 1. The equivalent code is this. Now the second line of code. Variable L varies from a lower bound to upper bound. Here also lower bound to upper bound. Here also lower bound to upper bound. Here the lower bound and upper bound are the same. The lower bound is always 0. You can see that. Now what about the upper bound? This upper bound you can generalize it as n minus p minus 1. For example, you can see that this one. Here n is 4. The value of p is 1. So 4 minus 1, 3. 3 minus 1, 2. So this is nothing but 2. Similarly, here also this is n minus p minus 1. Here n is 4. The value of p is 2. So 4 minus 2, 2. 2 minus 1, 1. You can see it is 1. And here also the upper bound is n minus p minus 1 because n is 4. The value of p is 3. So 4 minus 3, 1 and 1 minus 1, 0. So the upper bound is always n minus p minus 1. So we can say L varies from 0 to n minus p minus 1. You can see that here L varies from 0 to n minus p minus 1. So this becomes L, this becomes 0 and this becomes n minus p minus 1. So your code will be for int L is equal to 0, L less than or equal to n minus p minus 1, L plus plus. The code is written here. For int L is equal to 0, L less than or equal to n minus p minus 1, L plus plus. Now the third line of code. If the left element greater than the right element, I need to swap them. So like this. If the left element greater than the right element, swap the left element and the right element. Now how will you get the left element? How will you get the right element? The index of the left element is there in variable L. So this index, the index of the left element is there in variable L. So this one is there in variable L. Now if this is L, what will be this? L plus 1. Again, if this is L, your left element is A of L. Similarly, if this is L plus 1, your right element is A of L plus 1. You can see the left element is A of L and the right element is A of L plus 1. So this can be replaced as A of L and this can be replaced as A of L plus 1. So this became A of L and this became A of L plus 1. Now swap left element, that is A of L, and right element, that is A of L plus 1. So how do you swap A of L and A of L plus 1? In order to swap A and B, the code is like this. So here, let me replace A with the A of L and let me replace B with the A of L plus 1. So T is equal to A will become T is equal to A of L. T is equal to A of L. Now A is equal to B becomes A of L is equal to A of L plus 1. You can see. Now B is equal to T becomes B is A of L plus 1. So A of L plus 1 equal to T. So in order to swap A of L and A of L plus 1, this is the code. This code. Now associated with the if, multiple statements are there. So you need the bracket. You need the opening curly bracket and the closing curly bracket. Now here I made use of a temporary variable T. I should declare the variable T. Array is an array of floating point numbers. So certainly this variable T should be declared as float T. So this is the code that we make use of for bubble sort. So when you study for the exam, the code must be studied like this. Step 1. Pass number varies from 1 to n minus 1. You will get this line of code. Second line. L varies from 0 to n minus p minus 1. So you will get this line of code. Third one, if the left element greater than the right element, so you will get this. Now swap left element and right element. You can make use of this code. Here A should be replaced with the A of L and B should be replaced with the A of L plus 1. So when you study for the exam, remember this code based on this example.